Mr. Benjamin Miller, who's a Vice President of Professional Services and Research Development at Dragos, to deliver the keynote speech of today titled Defending Our Industrial Automation.
Hello, thank you for having me today. I don't go out and do international conferences too often, maybe once or twice a year, so I was a little bit nervous coming here as far as the topic area, and then the last panel talked about information sharing and OT, IT divergence and convergence, and I feel much more comfortable now. I'm much more relaxed. This is exactly the same discussions that we're having everywhere. The picture there is Niagara Falls generation power plant. It generates 2.6 megawatt. I love critical infrastructure slightly more than I hate heights, so I took that picture and then ran away. But what's interesting in the long-term view, 25 years ago when I first started getting into computers and exploring computer systems, I never could have imagined the real-world impact. To me, 25 years ago, what happened on a computer stayed on the computer then. What we're dealing with now is the physical impacts, not just to industrial processes, but the infrastructure that we have today. The background of Dragos, which is an industrial cybersecurity company, we focus exclusively on industrial control systems. At the structure of our team is exactly as it was when we first started, which was focused on two key problems. And the lack of the workforce from an industrial control system security perspective, and how do you scale a workforce in a meaningful way, and then a lack of understanding of just what the types of threats that are out there for industrial control systems. So the background of how we're structured will give insight into the rest of the presentation of what I'll be presenting. But beyond just having software that we're deploying out there at industrial control system sites is two fundamental needs beyond that. One, we need insights into the activity groups that are out there, the threat actors that are out there causing impacts, because largely we don't have a lot of empirical data around that. We have anecdotes of one-off attacks, and this was several years ago, and we've been able to build out an understanding of what these attackers do, which I'll talk to shortly. The other challenge is the lack of expertise in the OT space. So we can have all the software developers we want, but if the developers don't understand the infrastructure, the OT challenges, the industrial processes that we're trying to secure, then fundamentally it's going to be a challenging problem. So my team is a professional services arm. So we're doing the incident response for our customers. We're doing engagements such as penetration testing, consulting, advising sort of services. So that expert-led and intelligence-led offering back into the platform is really the core focus of what we do at Dragos. To understand these industrial control systems attacks, there's two models that we should consider, and I'll lay out as background information. The first is the diamond model. The diamond model is a way to represent the attacks in a way that allows for understanding similar attacks happening over periods of time. It is really measured in a couple of key constructs. So the first, from an intrusion standpoint, a customer experiences intrusion, and such as a phishing attack, for instance. There is an intrusion there, yes. As more intrusions happen, the analysts might identify that these are very similar. They're coming from, say, the same servers, that they're showing the same patterns, and they're showing the same targets within that company is able to put a circle around those intrusions saying, hey, this is a set of intrusions. Similarly, you can start grouping these by similarities to a campaign. So a campaign is nothing more than a series of intrusion sets over time across a particular vertical, such as, say, Dragonfly was an original industrial control systems campaign. You can put a circle around that saying this is a campaign of activity, a campaign of intrusions. An activity group is the combination of multiple campaigns that are showing over a series of time similar infrastructure, similar capabilities, as well as similar victimology in the concept of either geographic area or vertical or subject matter. So when I talk about activity groups, it is not a piece of malware or a particular type of attack. It is a series of campaigns over time that we can arbitrarily draw a circle around saying these are all unique enough and similar enough to each other that we're going to call them an activity group, and we're going to track them over time. The next model is the ICS attack kill chain. The kill chain is a series of steps that the attacker has to go through in order to have a successful attack. So if they're putting a sustained operation to intrude upon an industrial control systems network, they're largely going to follow these steps both on the IT and OT side. What you see in the blue top part is stage one, often considered industrial or IT specific, which is that initial beachhead into the computer network, and then that moves down into the industrial control systems in stage two. The key construct of the attack kill chain from a defender standpoint is if you're able to disrupt the attack anywhere along the kill chain, the attack itself is no longer successful. The attacker has to stop, regroup, and relaunch an attack. Ideally, the higher up at the beginning phases of the kill chain that you attack, you're raising the cost on the attacker and diverting the attack. So what does that mean from an industrial control system space? What does the threat activity out there, what do we look like today? 3 years ago, we had anecdotes of various types of attacks. Dragos has been monitoring currently 11 activity groups that have a interest or capability to disrupt and create intrusions within industrial control systems. These are largely broken up into three broad categories. Those that are aspirational, which is represented in the lower tier, as far as attacking critical infrastructure companies, networks, doing reconnaissance of third-party suppliers and vendors. That includes the activity group names such as Covelite, Magnalium, Raspite. These activity groups are largely growing. This chart was made a couple weeks ago, and we've since added hexane, parasite, and wasamite. So that's continuing to progress. The differentiator between the two between the three, allanite and dimallium, have demonstrated success into industrial control systems environments with the focus of doing reconnaissance, information grabbing, and bringing them out of environments themselves. And then the top tier from Electrum and Xenotime has demonstrated actual capabilities. So capabilities in the form of Electrum, in the form of the Ukraine 2016 attack, which disrupted a transmission substation for approximately an hour. It used a piece of malware that was delivered several hours before the launch of the attack. However, the campaign itself had a duration of measured in months. But the malware capability is unique in that it was tailored towards electric substation automation systems in particular. The protocols and the modules associated with that was designed for that particular environment. And Xenotime is the activity group associated with Trisis, also known as Triton, a piece of malware that affected a safety instrumentation system in 2017 and tripped a refinery several times before it was detected of being embedded within the safety embedded systems. The key takeaways here are twofold. One, all the activity groups out there, including Xenotime and Electrum, and they are still active. They by the very concept of being an activity group, are multiple campaigns over time. So they are someone that we're actively tracking, and they're developing new capabilities. They are focused on reconnaissance and pre-positioning themselves and extending their tool sets into other vendors and other OEM capabilities out there. And largely the other two teams are doing reconnaissance and targeting, but the general theme is from an activity group status, the best of the best, Electrum, Xenotime, are all still in a very capabilities development standpoint. In essence, this is only going to get worse as these teams build out these capabilities. And largely, they're building out these capabilities and infrastructures that are, I would say, the least mature from an industrial control systems perspective. So you could spend a lot of money developing a capability in a lab to test and create these capabilities, or you could just find a very low mature site and create an intrusion in their environment to be able to test and develop your capabilities. That's largely what we're seeing today. Now, I had mentioned my team from a professional services aspect. We do penetration testing. So we are breaking into lab environments. We're breaking into facilities that may be in a maintenance or in the early provisioning steps. And we've started tracking my team's activity, my team's tools, tactics, and procedures to see what they're capable of doing and feeding that back into how we understand what attacks could look like themselves. We call this activity group internally Kyberate, and the idea started initially of emulation of known attacker TTPs from being able to emulate Electrum or Xenotime in a customer environment and show that to, and we've since grown that capability into our knowledge of the particular product systems that are out there and being able to manipulate them in interesting and odd ways, which I have some areas I'll talk to shortly. But largely, if we're thinking from what is emerging, where are things going, it is not on how do I attack a Windows host, it's how do I understand the environment to gain a foothold on having an impact on the industrial process itself? And that is both product specific as well as facility specific on its implementation. And when you start gaining that knowledge, gaining that OT knowledge and that experience and being able to apply it in these settings, you can have some amazing capabilities that are demonstrated. Which gets to the idea of current state environment manipulation. So whether it is some of the other activity groups that we're tracking out in the wild or my team itself, the area of focus from an OT perspective, where it is valuable from a defensive perspective of putting resources into, is understanding the concept of environment manipulation. So the easy cases of environment manipulation could be in the form of the Ukraine 2016 attack, or I'm sorry, 2015 attack, where they brick the remote terminal units that are out at the substations, the serial converters, thereby limiting the operator's ability to restore operations. They essentially had to put folks in trucks to drive out there to manually return back into operations. So the attacker manipulated the environment as part of the attack. It makes sense. Certainly if you install a piece of malware, you're technically changing the environment as well. So those are easy environment manipulations. Some non-obvious manipulations are manipulations of your security controls. So in prior cases, there's been manipulation of the authentication systems in order to allow the attacker into the environment easily. Manipulation of multi-factor authentication, setup of user accounts, changing of the firewall configurations themselves in order to gain access into the environments. So when we're largely talking about OT infrastructure that is designed to monitor the industrial process, at the end of the day, we have nothing designed to monitor the monitoring systems themselves from a security perspective. So as these environment manipulations are happening, do we have logs? Do we have information? Do we have triggers and warnings that this is occurring? Largely, that is not the case. Some of the areas that my team is exploring from an environment manipulation, which I would like to think that we're at the top of the pile from a capability standpoint, are tactics such as finding an SSH port open from the DMZ into the OT network. We have the default credentials there. As a typical finding would rate that as a low finding, that we're able to log in, have non-admin access credentials, but not really be able to do much. Certainly it would be a finding, medium or low-level finding. But we were able to use that to then enable a remote desktop onto that server, which gained us access into the operator view, the HMI view, that we were then able to tunnel through SSH, view that, take screenshots of the industrial process, and then exfil it out. Well, that just completely changed the narrative of that finding for that customer. In another example, we had a software vendor's HMI. We had a read-only operator account on that human-machine interface. We were still able to have global view of I should say, read-write view of the HMI screens themselves, and we were able to manipulate them to actually drop software for anyone who viewed the HMI itself. So that is not attacking the Windows host, it's attacking the application itself and understanding if you want to create a kind of a new capability of manipulation for the operators as well as the engineers, you can do that through that software. Finally, from a just trend of technology itself. This has been going on for 20 years. This isn't an OT problem or an IT problem. This is just where technology is headed. If you gave technology a will and said, what do you want, technology? I would argue that technology wants to be more connected. And as you have more connection, you get more technology. It becomes a feeding cycle. So when you're looking at very remote sites that have historically had a VSAT connected to it, maybe half a megabit per second connection link, what happens when you give them a gig a second link? It's going to lead to more technology, it's going to lead to more access and more capabilities of those devices. And largely, if it's not done right, it's going to create more capability for the adversaries themselves. So what we have here is a state where the activity groups are largely closing that gap. The previous panel talked about the challenge of OT versus IT. From a defender perspective, the attacker perspective, OT and IT, there is no divide. There's convergence. The attackers out there have OT capabilities, they have IT capabilities, they have industrial process and process control experience, and they're using those to generate attacks. And now you have this combination of whether you're thinking of Industry 4.0 or just the connectedness of where we're going with these environments of putting us in a state where they're able to leverage even more technology to gain access into these environments. This is where we're headed as an industry today. So 5 things that we can do about it. This talk is about defending industrial environments, not appreciating the problem that we have. There is a lot of things, straightforward implementation that can be done to drastically improve the environments. It starts off with knowing your infrastructure and knowing the networks that are deployed, not as they were necessarily designed, but as they are today, and having an understanding of what assets are talking to what other assets, what the architectures are, what kind of zoning and security controls may exist. Largely what's on paper is quite a bit different than as implemented. So that's stage 1, which sounds straightforward, but can be really challenging and is the beginning starting point for a lot of the facilities out there. Secondly, is something that Dragos calls collection management. So we actually, on our public website, there's a collection management framework white paper. You can download it. It was released, I believe, last year. And it's around the idea of, well, if I understand the adversaries that are out there, the activity groups that have certain capabilities, and I have this industrial environment that I need to instrument in order to find it, do I know what I need in that environment to collect that data, or do I have zero visibility? Can I go back 6 weeks? Can I go back 6 months with logs? The collection management framework is essentially the best security tool ever created, which is Microsoft Excel. And using Microsoft Excel to document from an operational perspective your visibility in the environment. So that if a security operations center says, hey, we have this new technique that is being seen, how do I determine if that's in my environment enough? And the collection management gives you an exercise to go through. Yes, we do have this capability. We can go out and actively hunt for it, or if we need to respond to it, we actually can. It's taking that proactive step of just understanding what visibility you have in the environment, because largely the state of industrial control system space is that it's 0 or near 0. You can take both of those, the asset list, the collection management framework, and start pre-positioning response capabilities as well. If you have bringing a digital forensics person into a control systems environment does not produce amazing forensics, because of the forensics individual does not understand control systems. They don't understand that you can pull error logs from controllers. They don't understand the application logs, the application data that's available in the environment, and how it can help pull together a forensic story. So ultimately doing response, doing root cause analysis, doing forensics, it's all about being able to tell a story from the very beginning to the very end, and using the data points in order to tell that story. If they don't know where the data points are, then they can't tell that story. They can tell that a particular Windows host had experienced an intrusion, but they can't explain what happened on that host without that process control or operations technology system administrator and having a conversation with them ahead of time can generate playbooks and runbooks on what to collect and how to analyze those systems. That's step 3. Step 4 is certainly system hardening. Architecture can, systems architecture can sometimes be a subject area, but there's not a lot of architecture there, right? It's just like one big flat network that hasn't been architected from a security standpoint. It's been architected from a industrial process standpoint of what works. And when it's working, don't break it because it's working. Bringing in best practices of hardening Windows hosts, setting up firewalls, strengthening egress filtering, and understanding the process. So the goal here isn't to take IT best practices and copy and paste it into industrial environments. It's to instead understand the industrial process to enough of figuring out where your crown jewels are, the critical systems that can truly have an impact, and creating controls around that. One of the other white papers I would lead you to on the Dragos website is a white paper called Consequence-Driven Analysis. Consequence-driven analysis is essentially taking the worst day possible that you may have in your facility, understanding what that is from an engineering level. That particular compressor, if it goes out, it's going to be a really bad day. Well, from there, you can start rewinding all the devices that have control elements or capabilities to influence how that compressor is working, and feed it into your collection management framework. So you can say, this particular controller is super important, and it only has communications to these 20 assets. Well, now all those 20 assets are in scope from an OT perspective, and you can start building out that capability approach. And then finally, OT visibility in general. And I touched on this, is I would say challenging within these environments. Certainly gaining access into a network and deploying a solution there is the first step. But you also need to be able to collect hosts and other data points and being able to feed that up to your defenders. I would say largely the discussions we've had as a community for the last 10, 15 years has largely focused on doing architecture reviews, making sure we have a patching program, and making sure we're doing what we can to lower risk. The direction of the adversaries, the direction of our technology, I'll say we need continual monitoring and defense of these solutions in order to have a lasting impact, because the change rate and the capabilities that are shown out there are more sophisticated than we need to deploy a patch. They're to the degree where there's environment manipulation that can happen in any odd way, because at the end of the day, it's a human behind the keyboard and not a piece of software, so they're unpredictable. And so having defenders out there in order to get out in front of the attackers, especially on the industrial control system side, is where we're headed. So with that, I thank you for your time.